that how to decide that a point is inside a region, the set, or outside the set. How should I define inside, outside, and boundary? These are the three things that for this set actually. The things which are inside the set, the things which are outside the set, and the things which are
on the boundary.
In terms of bonds, can you explain in terms of bonds?
Yes, we can define it, sure. But it would be like revealing answers. Okay.
Sir, किसी point से compare
How can I say that this point is really inside the set, and this point is outside the set, and this point is on the boundary?
So
Think very naturally. Think from, naturally. And try to come up with the definition, no matter how stupid it is, don't worry about it.
सर एक ओपन बात तो मैं सर हमने जो चीज पढ़ी थी कॉम्प्लीमेंट ऑफ कॉन्सेप्ट कि जो चीज ए से अंदर हो तो हम कोई भी पॉइंट फॉर एग्जांपल अगर बी लेते हैं
One thing is that it should be in the complement.
तो बी हम कोई पॉइंट लेते हो ए से बिलोंग करती है अगर कोई बाहर पॉइंट सोचते हो कहते बिलोंग करती है इस कॉम्प्लीमेंट से तो थोड़ी
Okay, it should have some relationship with it. ठीक है. और कोई ऐसी चीज.
सर अगर हम इस तरह करें कि कोई से दो पॉइंट्स लें और उनको आपस में मिलाएं,
ठीक है.
हमें बाउंड्री नहीं आनी चाहिए.
That's a very good approach actually to think that. Okay, you take another point, okay, and you should draw a line that shouldn't cross the boundary actually. Okay. At the moment I have no argument to counter it. Can we use this as a definition?
But when we will have a points on the boundary, how can we see?
But he is saying that I'm talking about the points inside the set. So he's not talking about the points in the boundary. So in other words, can you find another point, okay, a point, okay, and you draw a line, and that line doesn't pass through the boundary. Okay. By the way, we have a name for such kind of sets. These sets are convex set actually. We will talk about them later.
इसमें से हमें पता नहीं चलेगा कि वो इनसाइड है या आउटसाइड है. अगर सर हम एक पहले हमें बाउंड्री मिली हुई वो आउटसाइड है, अगर हम दूसरी भी पॉइंट ले रहे हैं वो भी आउटसाइड है, तो हमें ये पता नहीं चलेगा कि हम जो डिस्टेंस अब ये मतलब कि दो कंडीशन से हो सकता है कि बाउंड्री को टच ना करे. एक तो कंडीशन ये है कि दोनों पॉइंट्स इनसाइड हो, एक कंडीशन है कि दोनों पॉइंट्स आउटसाइड हो.
That's a good point actually. That's a very good counter. What if you have 2 points outside and you draw a line? That's a very good counter. Who says that we people are not creative? We all are creative. We just have to think creatively. So what should be the real trick actually to make sure that
अगर एक पॉइंट के लिए उसका
तुम किताब पढ़कर आए हो. तुम किताब पढ़कर असद किताब पढ़ के आए. He's giving you direct answers. The best is that at the moment I'm calling to your creativity. I'm calling to your creativity. You can think about something that really can help you out in this situation. Anyway. So how do we define that something is inside? Okay. In the region S is that that's a very simple definition. A point is inside a set S if you can draw a really small bar around it, small enough ball around it that is entirely sitting in the set actually. That is entirely sitting in the set. So imagine you take this point, or say this is inside the set. Okay, it is really inside because I can see a little inside around it, which is part of the set actually. So this ball is kind of making sure that you are inside. But now imagine if you take a point on the boundary and you try to draw a ball, no matter how small or how big it is, you always some part of it is going to be outside ball and some part is going to be
Inside.
the inside of the set actually. And how about if you are outside? You take a ball, take a point, that point is outside, you draw a ball around it, and that ball is entirely outside the set. Okay. Isn't that a clever way to define inside and outside and the boundary of the very clever? It's a very, very clever way to define it actually. Okay? So what we just said, let's try to put it in the form of a precise definition. So we say that, okay, a point A in S is interior. Okay. By the way, this interior has a meaning actually. Now it's a technical meaning. Okay. Interior of S if I can find, if we can find a radius R, okay, such that you draw a ball centered at your given point of the radius R, and that ball is entirely sitting in S actually. Very simple definition. A point is really inside a region, and it's very intuitive definition. If you draw a ball around it, and that entire ball is sitting inside. In other words, you have this point and you can find a really small chunk of this set around it, which is inside the set actually. So it's like this ball around it is making sure that this point is inside the set. ऐसा ही है. Think about it. अगर ये ball कहीं बाहर हो, if this goes outside, so it's gonna tell, you're not inside. And no matter how close you go, if it is inside, you can always find a tiny ball actually that can separate the boundary and that point actually. Roughly, you can also see it from that point. So this ball is kind of separating, this from the boundary. So boundary has a particular definition. I'll get into it. So that's the first part. So are we happy with it? Okay. So what's the second definition? So a point A is exterior. Okay, maybe I take another point B for example from outside. B from S complement is exterior. Okay. B belongs to S complement, but B in Rn is exterior point of S, is outside point of S, if we can find a radius positive such that you take a small chunk around that by ball, you mean a small portion around the point A, and that portion is entirely sitting outside as complement. Okay? Is it making sense? And the third thing is, if a point is point C, for example, in Rn, okay, is neither exterior nor interior, okay, it's called a boundary point actually. Okay, we call it a boundary point. So boundary point which is not either inside nor inside. In other words, if you try to draw a ball around it, it is neither contained in S nor contained in S complement. Okay, that's what it means actually. All right. Collection of all interior points. Okay. Collection of all interior points, you denote it by S circle. Okay. Or maybe I'll use the bookish notation. So int of S. So int of S is what? Is the set of all interior points. Okay. And exterior of S, we're going to denote it by this. And by boundary of S, I'm going to use this partial S actually as a symbol for the boundary of S. Okay. What are some of the immediate things that you can say about these results? I'm just making some remarks. Okay, to nahi hai?
No, sir.
I hope. So, at the moment, what we are trying to do, so we define nearness, and then we want to say, okay, which things are inside the set and which things are outside the set and which things are boundary of the set. And you see that these all will be very useful when you want to define limit and the continuity, okay, for the higher dimension. Okay. I'll do some examples of this as well. There are some remarks which are pretty much obvious. Okay. First remark is how about if I compute the exterior of S complement? What would be that? Just see the picture. So exterior of X complement must be interior of S. So that's intuitive, but you can also prove it through definition, because these two are sets. So try to prove this through definition. Take a point from X which satisfies this condition, show that that same point would satisfy this condition as well. Okay? So if you take a point, draw a ball around it, is subset of S complement. If it is subset of S complement, that means that it's subset of S complement complement. That would be S actually.
Yes.
Okay, so try to prove it for yourself. Well, you can see it pictorially. And similarly, if you take interior of S and you take exterior of S and you take boundary of S and you combine them together, what are you going to get? Everything. Everything. Okay? Everything.
सर
There is something.
जो आपने पहली कंडीशन लिखी है इसमें जो एक्सटीरियर कॉम्प्लीमेंट आप फेस है तो ये बाउंड्री पे भी हो सकता है ना, इसके अंदर तो नहीं हो सकता।
डेफिनेशन एक्सटीरियर की क्या कहती है? एक पॉइंट एक्सटीरियर होगा एक सेट का कि अगर एक बॉल हो वो इस सेट के कॉम्प्लीमेंट का सबसेट हो। तो आप सोचें कि अगर मैं एक पॉइंट लेता हूँ B, वो एक्सटीरियर है S कॉम्प्लीमेंट का, तो फिर उस पर मैं एक बॉल ड्रॉ कर सकता हूँ जो कि S कॉम्प्लीमेंट के कॉम्प्लीमेंट में होगी। ऐसे है? अगर यहाँ S है तो यहाँ S कॉम्प्लीमेंट हो, तो अगर यहाँ S कॉम्प्लीमेंट हो तो यहाँ क्या होगा? S complement का complement, but S complement का complement is basically so above definition is satisfied. Already see it. Let's do one example. We can finish it. So at the moment, I'm just a bit careful, bit slow, so that we can learn this basic stuff. But you will see that we want to. Basically, we are trying to build a theory of multivariable calculus, and we want to. We can see this as systematic things. Usually, when we see this calculus stuff, we see that there is no relationship between them, and you will see that there is a relationship between that. Okay, you can take one thing and define things in terms of others. Okay, so consider a set. it consists of those points for which the absolute of x is less than or equal to 1 and absolute of y is also less than or equal to 1. And I have another set S2, it's a collection of, so this example is in n equal to 2. Okay? And you have another set xy such that absolute of x is strictly less than 1 and strictly less than 1. So let's try to make a picture of the first set. So how does the first set is going to look like? In other words, if you want to plot this guy, so how to plot the inequality? So what would be absolute of x less than or equal to 1?
X less than
Minus
or
one.
equal to
Minus 1.
Okay, so you have a line that goes from -1 to 1. And how about y bigger than or equal to 1?
So what lies between minus and 1?
Okay, so let's put them equality at okay. So it's gonna be also y equal to y less than or equal to 1. Okay. The other thing that you can do is roughly you equate them, and you know जैसा आप करते हैं usually when you plot, for example, inequality. So you equate absolute of x equal to 1. So what would be the solution for absolute of x equal to 1? So it's going to be x equal to -1 and x equal to 1. So you're going to have a line, okay, that goes through 1. And it will be a line that goes through -1. How about in case of y? So you're going to have a line, okay, -1 and +1. This is going to be roughly the picture of it actually. Okay? So if I, for example, so S1 is which region? This region within this box section. Okay? And what would be the coordinates of this, you know, for the vertices of this box? So 1, 1, -1, 1, and this is 1. -1, -1, and this would be 1, -1 and 1 -1. So you have it actually. Okay? So what set you are talking about? You are talking about this set. Okay, that's your S. And how about S2? Boundary. Now if I say, give me in set theoretic form the interior of S1. So what would be the interior of S1? But I want to write a set theoretic description actually. I want to write it in a set builder form. So it's a collection. So what is interior? So everything except these, what do you call, boundaries. So how should I describe it actually? So it's a collection of x, y such that
Mod of x less than 1.
less than 1, sir. Less than 1.
so mod of x less than 1, is it enough?
Mod of y
Not a y.
Mod of y is less than 1. This means that interior of S1 is basically S2. Isn't it? So interior of S1 is interior of S2. What would be the interior of S2 by the way? It would be same as S2. Okay? That's an interesting property. The interior of set is set itself. Set which doesn't introduce boundary. For that you expect the interior of set to be set itself. Let's talk about exterior and then come to the boundary actually. That would be good actually. So what would be exterior of S1?
mod of x greater than 1.
नहीं, exterior of S1 is going to be S2 complement. The S1 complement, everything except S1. ऐसे ही है, because if you take S2 complement, the boundary भी आ जाएगी. It shouldn't include. So S1 complement. ठीक है? And what would be the exterior of S2?
S1 complement unit boundary.
So it would be S1 complement as well. So what would be exterior of S2? So take this boundaryless set actually. So what would be exterior? Again, I think one of the things that you are confused in is this important thing. So that's the interior of the set, that's the boundary of the set, and that's outside of the set. Okay? Boundary may or may not included in the set, but it doesn't mean that it's not a boundary of a set actually. It's really a boundary of a set, but it's not included in the set. That's what is the key thing. That way. So include hona is a different thing, and so boundary हो सकती है set की और होगी ज़रूर, but it's not necessary that it should be part of the set actually. So if you take for example a similar kind of a square, which is what you call S2, so what should be the exterior? The exterior should be still what do you call this S1 complement actually. Okay? And here is a very interesting, and now you can think about the boundary actually. So what would be the boundary of S1? So from Rn, take away interior and take away exterior, whatever remains is the boundary. Okay? And similarly, you can see the boundary of S2. Now you can see a very interesting question where I would like to add. S1 and S2 are two sets with the same interior, with the same boundary, with the same exterior, but they are different.
Closed and open.
That's what the key difference is. और ये define करने के बाद, from after that he talks about the close and open thing actually. That the real difference is that in S1 the boundary is included as a subset, okay, and in S2 the boundary is not included as a subset. ठीक है जी? So see you in next discussion. तो अब हम क्या कह रहे हैं? Friday को